Okay, so just a couple of quick trig identity examples. So this is a past HSC, I think it was 1997. Prove sec squared theta minus tan squared theta equals 1. A general rule of thumb is if you're totally stuck in these, you can always try and get everything in terms of sine and cos. It doesn't always work, but in fact in the HSC they said to do it this way by actually showing, by expressing sec and tan in terms of cos to prove this identity. And when I prove these identities, I always set it out like this. I always say, okay, the left hand side is equal to sec squared theta minus tan squared theta, and I only work on one side. And so then I say, okay, I want it in terms of sine and cos. Sec, third letter, C, so it's the reciprocal of cos, so it's 1 over cos squared theta. Tan in terms of sine and cos is sine squared theta on cos squared theta. That leaves me with 1 minus sine squared theta on the numerator, and we have a common denominator of cos squared theta. So we're pretty close now. We've got everything in terms of sine and cos. Now if we just quickly flick back to our trig identities, back here they are, we see that we've got this identity sine squared plus cos squared equals 1 in our toolbox. Sine squared plus cos squared equals 1. Now knowing that too many bits of paper. Knowing that sine squared plus cos squared equals 1, I can see that if I rearrange this, I can get cos squared theta must be equal to 1 minus sine squared theta. So using this rearrangement of our identity from our toolbox, I can substitute for the numerator. Instead of 1 minus sine squared, I've actually got cos squared theta. So I've got cos squared theta over cos squared theta. And cos squared on cos squared is 1. Going back to what I was trying to prove, I had to prove it was equal to 1 equals to the right hand side, and sum up, finish off the proof by a little square, or some people like to put in QED. Okay, a second example. Prove cotan x plus tan x equals cosec x sec x. Okay, so if we run through this example, again, I'm just going to start with the left hand side. I'm going to say it's cotan x plus tan x. Asked to prove it's this. Looking at it, doesn't look like there's a great deal you can do with that. So again, I'm going to say, well, I'll use my rule of thumb. I'll express everything in terms of sine and cos. And so with cotan x, I know it's 1 over tan x, but that is also cos x on sine x. And tan x was sine x on cos x. And that comes from our trig identities. See if we can do this smooth as silk this time. There it is, cotan x, cos on sine, tan x, sine on cos. Straight out of our toolbox. So now we've got two fractions. Maybe there's a little bit more I can do with these now in terms of adding them. If I go to add them now, I'm going to need a common denominator. So my common denominator will be sine x, the product of the two on the bottom. So I'm going to put all over sine x cos x as my common denominator, which means I need to multiply this term by cos x. So cos x times cos x is cos squared x. This term has to be multiplied by the sine x, so that'll make it sine squared x. And then if you've been paying attention lately, you would notice sine squared plus cos squared equals 1. So I have 1 over sine x cos x, which is starting to look like what we need. If keeping in mind we need to get to cosec x sec x, and they're reciprocals of sine and cos. That's pretty much what I have here. I can just separate it into 2, 1 over sine x times 1 over cos x. If I want the reciprocal, the third letter tells me which one it is. That one's going to be cosec x. And that one's going to be sec x. Okay, and that's obviously equal to my right hand side up there. So equals right hand side. Again, end of proof.